This is Bits&Chips, I'm René Rijmakers. In September 25, I recorded an interview with Hamed Sadeghian of Nearfield for our semiconductor special in Bits&Chips. Separately, I recorded also 30 minutes with Hamed about system engineering. How does the founder of one of the most well-known scale-ups in the Netherlands look at that art? What is system engineering to you in general? What does it mean? What does it mean to your company?
Discipline of where you're working, discipline of managing a complex system developments to me, from customer requirements, design, architecture, integrations, and bring it throughout the entire life cycle. And I emphasize on the entire life cycle, because often that is underestimated.
Are you living a life as a system engineer, or don't you define yourself as a system engineer?
Yes, we do, and I do, certainly. I look at it as an end-to-end responsibility. It's not just defining the architecture, it's bringing throughout the whole life cycle again. So yes, as being a system architect, system engineer of certainly quite some of the developments at Nearfield, products at Nearfield, but even with other companies, had the privilege of also at ASML, key projects, applied material.
Can you name a few learning moments and inspirations for you? When did you actually, what do you remember in your career as really learning moments where you got a grasp of what system engineering really was, and what did you carry on?
It's about experience. So you can read, you can do all kind of training, you don't become system engineer. Similar that you can read about riding a bike, you cannot ride a bike, but reading the book and get training. You need to get experience, you need to ride, fall, make mistakes, and learn. This is the same with system engineering. So you need to have experience over projects or developments to gain experience on multi-disciplines, on different disciplines. Because as a good system architect and system engineer, you should have a very good view on what is feasible, what is not.
Do you profit as a CEO from being a system engineer?
Absolutely, yes. Yeah. I'm still the CTO of the company, so a lot of decisions, is mixed in a sense that, it's about risk management. A good system engineer will manage unavoidables and avoid unmanageables.
Can you give examples of that?
Examples is about, what to focus, what is feasible, what is not. In developments of equipments that we do, it's very risky and it's very difficult to envision whether will it work, whether some of the risks are showstopper or not. And you need to be able to make decisions while you don't have much data. And that's one example. Even more important is onboarding people with your vision. System engineer, system architect is about also that you can bring group of experts throughout the whole life cycle, whether that is life cycle of a product development or a company. And that is, to me, has been also a big learning. It's not about tapping on the shoulder only and be nice. No, you should be blunt, but you should be able to give that vision to others, that they also understand it.
So that's also part of your job.
Absolutely, yes, yeah. And I had some inspirations of some people in the field as well.
Can you name a few?
Yeah, I had a privilege of dealing with Martin van den Brink for a specific project and how he approached some of these decisions.
Can you?
No, it's it was secretive, so I cannot. But the approach that way before in the architecture phase, why this is not feasible, why it will fail. Biggest learning for me was What is the driving requirement? What is the utmost important requirement that you don't allow easily compromise? You know, often in system engineering, you can be tempted by experts. Okay, well, this budget, this development, this feature would help a lot, while you need to understand where else do you pay penalty?
Yeah.
There is no free lunch. You pay for it, but where do you pay? And you don't pay by hitting the productivity on the scanner or our metrology systems. The same with applied material, worked with Ron Naftali, also a good architect, I would say. That helped a lot.
Maybe you can tell me about how a system engineer has to prioritize his time and attention. So what's most important?
What is important throughout the development will change. If we take the classical way, you start with your customer requirement or market requirement, then you define the product requirement, and you go into system requirements, you break it down, then you want to test it, you want to verify it. As a system engineer, you're responsible, you have to, take care of the whole journey. And your focus and your priority depends where you are, will change. But one thing that you have to have it on top every day is customer needs.
And how you make sure
because customer needs might or will change. A typical project, if you want to start the whole cycle, you are talking about a couple of years.
Yeah.
And in a couple of years, a lot changes. You need not only to develop, but you need to have a very good eye on how customers' pain and requirements are evolving, and what does it mean for your development, for the system, for the people, for the budgeting, and so on and so forth.
I can imagine that you can give examples of that, how customer needs and requirements changed over time.
Yeah, take the example of advanced packaging.
Yeah.
No, it was no advanced packaging a couple of years back.
When
Nearfield,
No.
But having, while you are developing different products, different systems, different features, different functions, knowing where the market is going, what your customer is doing, keep looking at their kitchen, what they are cooking, what does it mean for you, what does it mean for your focus, what does it mean in your total throughput budget, error budget, you name it.
And how do you keep track of the customers?
By being at customer.
Yeah. And how many times are you at customers? How often are you?
Very often. I don't recall a month that I'm not with customer.
So you fly to a customer, and what do you do? How do you organize your time there? How do you spend your time? And how often do you talk to customers? How different people do you meet? How does a trip look like?
It depends whether there is an escalation or not. But often, I would say it's not that I just talk to VP levels.
No.
But also with users of my system. For me, it's very important to hear them. Give me feedback, where you are not satisfied, where you want me to change, in our service, in our response, in the product, in user interface. Tell me.
So you also
and you find so much surprises.
Yeah. You also speak to the operator.
Yes, absolutely.
On the floor.
Absolutely, yes. Yeah. So different levels, they look at it from different angle. They have different need. They have different concerns, and we need to know it.
Can you tell me about surprises that you encountered during such conversations with people working at a lower level, like operators, not the VPs?
Well, operator, people responsible for metrology in the
those can be PhDs as well.
Yeah,
but the ones who are operating the machines.
Correct, or need the result of the machines and so on and so forth.
Yeah. So it can be simple, isn't it?
Yeah. On the user interface, because they want it simple, and I hear them. I remember a couple of years back, our user interface was not great. As a newcomer, when I had the first ship, a lot of customers, I don't like this, Look at CDSM. This is simple. This is not simple. And I said, okay, I want to make a list, feature by feature, what you don't like. Now, we came up with, I think, a list of 50 to 100 items. And I said, great. Now, make the first 20 the top priority ones, those that I have to change immediately. Made a priority. And then the team, we started, deal one by one, solve it. Simple, but important. I remember more, now than I realized, Martin van den Brink, I remember, metrology, a couple of years back said, these metrologists are like a beauty shop, they fall in love with their equipment and it's very difficult to change it. It's true. Yeah. It's true. They fall in love with SCDSM, and then they will try to do whatever is possible to get that CDSM working.
You're talking about the user or the...
I'm talking about user. I'm talking about user. Yeah. So we got those lists, and the team, the software team here, start to develop in it according to what they want. I remember one time I said, I want to have the demo because I want to feel the pain of customer. So I ran all these features on the user interface of Quadro and feel as a user, is it good enough or not?
Mm-hmm. You yourself did
Myself, that? Yeah, absolutely. So, that's simple thing, how to build the recipe. Responsiveness is very important, Friday afternoon.
If you're preparing for the weekend, you have to be able to still pick up that telephone.
Yeah, or the local team as well, that they can trust, that they can count on you is important. And you learn a lot as well, you learn a lot by being at the customer, of where you can improve, where you have to change, what you are doing good, what you are not doing. Because there is only one reason we exist, and that's customer.
Is there much difference between what you did in your company in Iran, where you developed machines for oil and gas and for steel, compared to...
Yeah, nothing comparable.
Not comparable, but you also have to listen to customers for oil and gas.
Yes, but the pace, it's very different. The aggressiveness, it's at the edge of what is possible. You don't deal with somebody who knows better than you.
Yeah.
Customer semicon, they know way better than you. And the biggest mistake that you can make is, I know better than my customer.
Mm. But you probably made that fault.
Absolutely, yes. There are reasons why they ask. And you better off understand that.
Mm. But if you want to make your point, like if you know they're not right, or if you think they're not right, how do you make your point? Because probably not very smart to insult a nation.
You don't start with making assumptions that they are wrong.
But if you feel they're wrong, if you feel they're on the right...
I understand what you are saying, and it took quite a lot of effort to change also this way of thinking here. You start your basic assumptions that you are wrong. Customer is right. Okay. So if they say, this result is wrong, as an example, it is wrong. If you start preparing your answer just to prove that you are right, it will go wrong. I am doing something wrong, you start with that. I'm doing something wrong. And you go to the 5 questions and 5 whys, and you go deep down to the bolts and nuts why you are wrong. Yeah. And on very few exceptions...
You dig until you know why you're wrong.
Yes. And in only few exceptions, you are right.
And then during that process, your customer will discover in very few times that you're actually right. But that doesn't happen very often.
Yes. Yeah.
Would you say that there is a Dutch approach to system engineering?
Oh, yes.
Or is there in general a good approach to system engineering? So what is the Dutch approach if you say...
Well, the advantages of, let's say, Dutch approach, there are disadvantages to it as well.
Yeah.
I think what is great is the fact that there is almost no hierarchy. You can speak up. So you can bring, as a system engineer, you are in a well position to hear different views, which are different risks that you might be blind to it.
Yeah.
I have seen examples in other countries where they see a risk, but they don't speak up because it just, you are not allowed to speak up.
Yeah.
Don't underestimate that.
If the boss doesn't see the risk, there is no risk.
Yes, exactly. And that, because system engineering is about managing the risk as soon as possible. And then you have time to mitigate it. I think we should keep it. This is really something in the DNA of Dutch culture.
How did you experience that for the first time, or in the very beginning when you came in the Netherlands? When did you become aware of that?
Yeah, well, of course you became aware of, okay, you can be direct. You are being.
You were a boss, so you probably already.
Yeah, I was a direct person. I'm not a politician, as I said. So I speak my mind, no matter who, and I will keep it like that. This is my principle, and this is what I've seen and observed. So I like it. There is an integrity in it. There is an honesty in it, and I like it. And it helps the system engineer. Well, what is not helping is it takes time to make decisions. You try to do a lot in paper to make it first time right, where in the other companies I've seen, a lot more. Also try and error. Don't underestimate. Sometimes it works. Try, fail, okay. Instead of well thought of the whole process. Making decisions sometimes it takes time because we tend to work out everything on paper, on the architecture phase, everything down to the detail before you start realizing.
How would we be able to improve that?
What we have done at Nearfield is a combination of the two. We call it early integration. So we define the risk. We go through the classical, from customer requirement, architecture, breakdown, a study, all kind of analysis, risk analysis. But we combine it in parallel, concurrently with early integrations. So the moment that you define, okay, these are my biggest risks in my error budgets, in my noise budget, in my throughput budgets, you define a test setup such that you can isolate that risk. And we tackle that. It has a flavor of try and error as well. But you know sooner if something is not working.
And how much do you depend on tooling for that?
A lot. So you have to design the tooling for that, you need to make the tooling for that in a minimum but viable. So I think we're better off combining systems engineering Dutch way with minimum viable systems engineering, where minimum is important, but viable. It has to be viable. Time to market is important. Time to market. That's sometimes by the Dutch approach you lose time to market.
That can be very painful.
Yeah, I mean, you go to the Dutch ecosystem, high-tech ecosystem, and you say, well, I want to develop such a thing. There is a lot of companies that offer, architecture phase, You take that, how long does it take? And you go to Southeast Asia.
They'll be way earlier.
Yes, so time to market for those that is feasible, you can also argue that quite some of them will fail. But for those that will not fail, time to market is way faster.
If you look back in the history of Nearfield, what were crucial system engineering decisions that you took?
I think it was in the architecture of Quadra. There was a big trade-off to make whether we go for combine, frames in terms of architecture, similar to, all the other names that you mentioned, where it's simpler, way simpler, but you pay back with noise and accuracy at a certain throughput. And whether we go to the extreme, like ASML with balance force, separate force frame, metro frame, which is the ultimate accuracy, but it's very complex. And I opted with a separate metro frame, which does not have the complexity of ASML scanner, making the balance force and balance mass and inertia, which is very complex. On the other hand, it enables us to bring throughput while we guarantee the accuracies, and not unlike the most simple architecture. That was really the core, and it still is part of why we get sort of repeatable performance and accurate performance. That was one. I think spending more time analyzing to be able to cope with floor vibrations. Sounds detailed, but very important, such that the system is robust against harsh environment. That we don't need the perfect floor. We can work next to the scanner because fabs are vibration is high. And at the end, if customer for production, not just for Torah, have to choose of the same performance, but one can work on these floors and they don't need a very silent floor, they will opt for that. It's a cost of ownership thing.
But you have a special vibration isolation system for that, or
it's about the design. It's about how you'd see it in your architecture to be able to with the use of feed forward, the use of correct budgeting on different frequencies that you are able to make this performance.
Did you have to sometimes come back to some certain decisions that proved wrong in the machine concept or in the market?
Yes. Oh yeah. Wow. Oh, many.
Many.
Yeah.
Even.
Yes.
So what happens at such a time?
You make an assumptions. You continue, and you will find out at a certain moment of okay, this is wrong. This will not give you the performance. And what do you do with it? Either an expert has tested and says, well, I see this. The way is to immediately tackle it. Whether even if it means that you go back, change the architecture of that module, of that part.
You even change the architecture?
Yes, you do that.
So you have to...
If you see the showstopper, and this is...
Showstopper?
Yes.
So
or you don't meet the performance.
Yes, you don't meet the performance, you see the showstopper, you have to actually basically...
You go back...
To the fundamentals.
Till is enough, you go back so much, and then you should do it. Otherwise, it's a failure.
Otherwise, so you actually you have to save the company.
Absolutely, yes.
Yeah.
And we had few of these cases. Yes, there is a setback, but we are way better off.
Would you say that the system engineering for semicon might be different than for other sectors, or or is it different in metrology, especially?
So in semicon, certainly, in equipment, semicon certainly is different than other markets, very different. The reason is that, look at the space. Also, system engineering is very important, but often you deal with years.
Yeah. And it has to work 100%?
Yes, and one time, often. Yeah. On the contrary, in semicon, time to market is extremely important. If you are a perfectionism approach, and you want to bring the perfect tool, you will lose node over node over node. You will miss them. So that requires a different way of dealing with system engineering. You need to be way more agile. And you need to be able to define, because that's very gray. What is minimum viable? What is the level? You know that you should not go for a perfect solution, but how much you compromise which is still interesting for your customer, which is still customer can use it, but not below that. That's minimum viable.
Can you give me a hint of how Nearfield has done that with delivering the first machines to the market? They were probably not perfect.
There are many features that we said, okay, you know, what would happen if we don't have it? Does customer stop using the machine or not?
So that was
my
the test.
Is it something that customer says, how the heck you don't have this? Minimum viable is that you lose face, but you don't lose credit.
So
the customer says, stupid, you don't have that feature. Yeah. Yes, they are not happy, but it's not a showstopper. Yeah. They say, great, I did it great. Of course I will develop it for you, but now I have time.
So you have to make sure you're credible, but if sometimes you lose face, and that's not so big a problem.
For me, always losing credit is way, you know. So always also I'll tell people, go as soon as you know you cannot meet what you promise, you go to customer, say, well, you know, I said I will deliver February, I cannot. I know today I cannot. You lose face, but you don't lose credit. Well, if it happens over and over, you also lose credit. But if you wait till January and say, yeah, February, then you lose credit.
And in semicon, that's deadly.
Yes. On top of that, is at the edge of what is possible. It's very challenging. You're dealing with, you know, fraction of a nanometers and so on and so forth. It's challenging. It's complex. It's nothing comparable.
What does that mean for the system engineers that are working at Nearfield? So, can you tell me something about how do they do their job? What's so special about making metrology machines?
Well, it has the aspects that I mentioned, you know, fast time to market, minimum viable, understand customer, and still be bold in our innovations, because it's so complex, it's so at the edge of physics that you can easily say this is not possible. So system engineers at Nearfield, I think we can still do better job in listening to customer. If you hold the mirror to me, I think we can improve there still. You know, listen to customer. What is their pain that you need to tackle in your architecture, that you need to tackle in your system engineering? What they are very unique is bring the first one up.
Which means the first
developments. You want to develop a new machine with a specific performance. Well, a lot of them we kill and say this is not possible, so we don't do it. But those that we say it's very challenging, but we pick it and they do it. They show it's feasible, meeting the customer requirements. You know, what we are scaling up, what we are learning. What we are dealing is, okay, now how to make it more repeatable, make it producible. That is still what we need to develop.
Yeah. How do you select them? How do you select the system engineer?
I pay way more attention, in general, not just system engineer, to the attitude rather than competency, hard skill. Attitude, behavior, mindset, number one. I hire for that. Also system engineers.
Probably you'll recognize that in a few minutes or maybe seconds.
Yeah. Yeah, yes.
You see everyone that's here to search for a job?
There are certain positions, certain vacancies that I don't. Okay. But I still do a lot. Yeah. Because culture is very important. Even if I don't interview, so there are quite some positions that I don't interview, but I definitely do introduction with them before they start, getting to know each other.
Now you already mentioned Martin van der Brink as somebody who influenced your thinking or helped you with
the thought process, yeah.
How much is ASML of an inspiration for the whole industry here?
For us is a lot, and I think for Netherlands a lot. Yeah. Significant.
The downside is that ASML takes a lot of oxygen, of course, takes a lot of attention. A lot of people are going to work there. What would ASML be able to do to strengthen the Dutch ecosystem without immediately putting out the money or the purse? How would it be if in their behavior? How would they be able to make Holland more innovative, or maybe a Nearfield in the future?
Well, we have a good relation, and honestly, where they could help,
They help.
I can easily go to Christoph, and he has help, and he will help. They are helping. Maybe behind the scene, not shouting, but they are helping. I still can go to all colleagues, you know. I still have relations with all colleagues, and they are very helpful. Yes, it takes a lot of, you know, oxygens and so on and so forth, but that comes with the mass, you know, as well. You know, getting more involved in scale-ups, maybe, where there is an advisory role, where there is maybe a minor investor role, to disseminate so much huge experience that is available there, spill it to more of these companies in the Netherlands. I think that would be great.
Yeah, there are a lot of experts in very small fields at ASML, right, who can spare a few hours advising smaller companies.
Indeed. Yes.
And there are a lot of companies with a lot of ideas here in Holland.
I think ASML can, I think, tolerate to have a couple of hours of these experts, you know, okay, do it. I would like to thank you, René. Your view, your sharp pen helps us as well, you know. I like that. It brings maybe sometimes also things that you're a bit blind to it. If there is anything that we at Nearfield can also help with this ecosystem, this beautiful ecosystem that we have here, really would be happy to do it.
Thank you very much, Hamed. And thanks for having me here in Rotterdam.
Pleasure.
I wish you good luck with Nearfield Instruments.
Thank you.
This was Bits and Chips. Thanks for watching. If you found this conversation interesting, please give us a like. It really helps us reaching a broader audience.